In this video, we're going to go through example number 7, which is an example combination circuit. This one you can clearly see is more complicated than the last. In this case, we have 6 different resistors, and hopefully it is clear to you that these 6 resistors are not all in series or all in parallel with each other. The very first thing I'm going to do, which I didn't do on that first video, is I'm going to label these with letters. The reason I'm going to do that is to distinguish between these 3 4-ohm resistors. I will put these letters in numeric order. In other words, the 2-ohm resistor will be letter A. For the 3 4-ohm resistors, I'm going to randomly choose the order. And then for the 5 and the 7, I'll go in order again. Just as in the last video, my first task is to find the equivalent resistance. The first thing I need to do is to find 2 resistors that are just in series or just in parallel with each other. You have a few options here, but the first option that I will choose is to combine resistors E and F. These 2 are in series with each other because as the current comes up here, if it travels through the 5 ohm, it has to travel through the 7 ohm before it gets back. So I will need to draw a new picture, and instead of 2 resistors up here, I will have just 1, and that 1 resistor will have the equivalent resistance of those 2. Pause the video and draw a new picture. This is what your picture should look like. Instead of having those 2 resistors there, I now have a 12 ohm resistor in its place. I now call that resistor EF because I combined resistors E and F to get there. Now looking at this picture, I still don't have a simple circuit. I need to find 2 more resistors to combine. Again, you have a couple options here, but the next set that I chose to combine were resistors B and C. Resistors B and C are in parallel with each other, and so when I combine them, I draw just 1 resistor in their place. Pause the video now and do that and draw a new picture. Include finding the equivalent resistance. Here's what you should get. There's just 1 resistor in its place. Its resistance is 2 ohms. One last time of combining resistors. See if you can figure out what to do in this one last step. Pause the video, draw a new circuit. Here's my last circuit. I combined those last 2 that were in parallel. That was resistor D and resistor EF. I combined them in parallel to get a resistance of 3 ohms. And I now have a simple series circuit, so I am finished. If I want to find the equivalent resistance of this circuit, I simply add the 3 resistances because it's series. And I get an equivalent resistance of 7 ohms. The next step is to go through and find current and voltage for each resistor. And as always, I will organize my information in a chart. Now you'll notice this chart is a little bit different than the ones that we had because I added in 1 extra column, and that's the column for the letter. Again, letting me know which is that 4 ohm resistor, which one am I talking about. So I will list the letters and the resistances, which I know, and I will calculate the voltage and current along the way. This is everything that I know right now. I have 2 out of the 3 quantities for the entire circuit, so I can calculate the current using Ohm's law. And I find that the current is 2 amps. Looking back at my picture here, the very last picture I drew, because now we have a ton of pictures that we drew. Looking at the very last one, these 3 resistors are in series. I know current is constant in series, so that means each of these 3 resistors has the same current running through it as what was running through the battery. I'm actually going to ignore my table a bit for now and just focus on these pictures. Since each of these 3 has 2 amps running through it, I'm going to write that quantity near the resistor. For each of these 3 resistors, I now know the voltage and the current, which means I now know the current and the resistance, which means I can calculate the voltage. I know everything I could possibly know about this picture, and so I'm allowed to move up to the previous picture now. There's my previous diagram. The difference between the former diagram and this one is that these 2 resistors are separate, whereas here it shows it as 1 resistor. These 2 resistors are in parallel with each other. We know voltage is constant in parallel. So the voltage of these 2 resistors is the same as the voltage of the one that we combined them to be. Which means each of these 2 resistors has a voltage of 6 volts. I will write that quantity near the resistor to keep track of what I know. I know voltage and resistance this time. I can easily calculate current. Go ahead and pause the video to do that, and unpause when you have the values to check with what I have. Hopefully you got 0.5 amps and 1.5 amps. I already know everything about resistor A and resistor BC because I have that information down here. And I know everything I can about D and EF. And so I'm done with this picture. I can move up a picture. The difference between this one and the one before, sorry about that. The difference between this one and the one before it is that resistor B and C are separate, whereas here they're as 1. And up here you'll notice that they are connected in parallel. Voltage is constant in parallel, and so the voltage of resistor B and the voltage of resistor C is the same as the voltage of resistor BC, which I have written all the way down here, 4 volts. So both B and C have a voltage of 4 volts. I will write that on my chart here. I know the voltage and resistance. I can calculate the current. This one's a pretty easy calculation. Each of these has 1 amp. I know everything I can know about this picture now because I know everything about D and EF, I know everything about A, and I know everything about B and C. So I can go up to my final picture. And the thing that's different in this final picture is that resistors E and F are separate. E and F we combined because they were in series with each other, and current is constant in series. So the current that flows through these 2 resistors is the same as the current that flows through this 1 resistor here. I'll have to scroll down for that current. 0.5 amps is that current. So I'll write that up here next to these 2 resistors. Each of these 2 resistors has a current of 0.5 amps. And so the last thing to calculate calculate is the voltage for each of these two. Go ahead and pause the video, calculate those things, and then unpause when you have those. You should have gotten 2.5 volts and 3.5 volts. The last thing to do is to organize your answers for these single letter resistors, all the ones that are in the original diagram, in the chart. And so I'm going to go through all my pictures. Anywhere I see a resistor that only has one letter labeling it, I'll put the current and voltage in the chart. I'm going to go ahead and tell you to pause this video, try doing that yourself, and then come back to the video. I'll have a completely filled out chart, and you can check your chart against my chart. Here's the final answer chart. Check your chart against mine. Hopefully your chart matches mine. So for a quick review over the process, we started off with this original picture and labeled each of the resistors with a letter, starting with the 2 ohm, working our way up toward the 7 ohm resistor. We then worked to find the equivalent resistance. We first combined these two resistors that were in series with each other and drew a new picture. Then we combined these two resistors that were in parallel and drew a new picture. We combined these two resistors that were in parallel and drew a new picture. And we were left with a simple series circuit. We were easily able to find the equivalent resistance then, which we added to our chart and calculated the current through the battery, which, because this is in series, is also the current through each of these 3 resistors. Then we worked our way backwards through the pictures using our knowledge of the voltage and current rules for series and parallel circuits to evaluate what the current and voltage is for each resistor in each picture. Once we finished and we knew everything for each resistor in each picture, we moved up one, looked at where the difference was, and found the voltage and current in that difference. That's the process you go through for every single combination circuit. If you'd like to try a more difficult example, see the next video.